Hello students, in our earlier video, we saw what happens when metals and non-metals react with water. We also observed that some metals like zinc, iron, copper and lead do not react with oxygen easily. So we tried to react them with water. Some metals like lead, copper, silver and gold still do not react with water. So in this video, let us see whether these metals react with acids or not. Here, we will perform an experiment to understand how different metals react with different acids. So for this experiment, collect all metal samples again, except sodium and potassium, as here we do not take sodium and potassium as sample because they react vigorously even with cold water. So if we take them with acids, they can harm us. Now we rub the samples with sandpaper if they are tarnished, that is, have dull surfaces. Let's put the samples separately in test tubes containing dilute acid. Let's start with hydrochloric acid first. We also suspend thermometers in these test tubes in such a way that their bulbs are dipped in the acid to record the temperature. Then we carefully observe the rate of formation of bubbles. We observe that the rate of bubbles formation is fastest in the test tubes having magnesium, while it is relatively slow in the test tubes containing metals like aluminium, zinc, iron, lead, etc. We also observe that there are no bubbles in the test tubes having gold, silver and copper. The bubble formation indicates that there is a gas being produced. Recall students, in our previous chapter, we have learned that when metals react with acid, hydrogen gas is formed. Let us verify this fact. For this, after a few minutes, we bring a matchstick near the mouth of test tubes having bubbles formation. When we lit the matchstick, we see that the matchstick burns with the pop sound. This pop sound is due to burning of hydrogen. This verifies the fact that hydrogen gas evolves when metals react with acids. From this experiment, we have also seen that all metals do not react in the same way with hydrochloric acid. Magnesium reacts with this acid and produces magnesium chloride salt. During this reaction, hydrogen gas also releases. Similarly, aluminium reacts with dilute hydrochloric acid and form salt and hydrogen gas. But metals like gold, silver and copper do not react with dilute hydrochloric acid. So now let us take another acid, that is sulfuric acid, and see how it reacts with the metals. Most metals react with sulfuric acid and give metal sulfates and hydrogen gas. For example, copper reacts with sulfuric acid and give copper sulfate and water and liberates sulfur dioxide gas. Similarly, aluminium reacts with sulfuric acid and form salt and hydrogen gas. Now let us explore what happens when the metals react with nitric acid. We see that copper reacts vigorously with nitric acid and forms an irritating brown gas. It is poisonous nitrogen dioxide gas. Note that this type of experiment must be conducted under a fume hood. A fume hood is a ventilation device used to capture, contain and exhaust harmful gases and fumes. When we further dilute this solution with water, it converts into copper nitrate solution, which is blue in color. Students, can you guess the type of this reaction? Yes, it is an oxidation reduction reaction in which copper gets oxidized and nitric acid gets reduced. Note students that hydrogen gas is not evolved when a metal reacts with nitric acid. It is because nitric acid is a strong oxidizing agent. It oxidizes the hydrogen and produces water and reduces itself to any of the oxides, that is N2O, NO or NO2. Student, it is interesting to know that gold does not react either with concentrated hydrochloric acid or with concentrated nitric acid, and so it does not dissolve in any of these acids. To solubilize gold, a special liquid is prepared called aqua regia. Aqua regia is a freshly prepared mixture of concentrated hydrochloric acid and concentrated nitric acid in a ratio of 3:1. it means that aqua regia contains 3 parts of concentrated hydrochloric acid and 1 part of concentrated nitric acid. Aqua regia is also called royal water, as it is one of the few reagents that can dissolve royal metals like gold and platinum. Even though neither of these acids can do so alone, aqua regia is a highly corrosive fuming liquid. Even though neither of these acids can do so alone, aqua regia is a highly corrosive fuming liquid. Now students, what are your observations on reactions in terms of temperature changes? Yes, you are right. The temperature rise is different depending upon the metal and the acid used in the reactions. Most of these reactions are exothermic, which means that the heat is released in most of these reactions, which gives a rise in temperature. We observe that the change in temperature in case of reaction of magnesium with dilute hydrochloric acid reaches 60 degrees Celsius, which shows that it is a vigorous reaction. The change in temperature in case of reaction of zinc with dilute hydrochloric acid reaches 9 degrees Celsius, which shows that it is a moderately brisk reaction. The change in temperature in case of reaction of iron with dilute hydrochloric acid reaches 5 degrees Celsius. Iron and dilute hydrochloric acid react slowly in starting, and then this reaction changes into brisk reaction. Temperature change in case of the reaction of copper with dilute hydrochloric acid is 0 degrees Celsius. Students, remember the case of copper? No bubbles were seen there. And now it is interesting to know that of the reaction of aluminium with hydrochloric acid. The reaction of aluminium with hydrochloric acid is quite spectacular. In the beginning, the temperature rises only around 5 degrees Celsius over about 15 minutes. And then, after 25 to 35 minutes, reaction speed accelerates vigorously and the temperature rise approaches 80 degrees Celsius. This is because aluminium has a protective oxide film on its surface. When these films burn, the actual reactivity of aluminium becomes visible. Thus, from this experiment, we can conclude that in the case of magnesium, the rate of formation of bubbles is fastest and the change in temperature is highest. From this, we can say that this reaction is the most exothermic. So students, in this video, we have learned that most of the metals react with acids and form salts and hydrogen gas. We have also seen that all metals do not react with acid in the same way. The decreasing order of metals in terms of reactivity with dilute hydrochloric acid is magnesium, aluminium, zinc and iron. We have also seen that copper does not react with dilute hydrochloric acid but can react with concentrated sulfuric acid and nitric acid.